What's up, everyone? So your tax dollars, whether you like it or not, fund the Tor Project through various governmental grants, whether you realize it or not. You're basically subsidizing the Tor Project, even if you never even donated a penny directly. Now, today's focus isn't another expose of developer incompetence or their PR department just straight up lying in a newsletter to everyone that's actually subscribed to it. Tor actually did something that's worth recognizing, and I think it's a genuine privacy breakthrough, I guess you could say, on some levels, because it's a architectural change, and I think that deserves some discussion. Basically, my approach remains pretty consistent when I make videos, whether it's darknet markets, companies, or just nonprofits that, advance privacy and liberty. When that happens, I document it. And, when they compromise or capitulate or, push surveillance, I try to expose that too. As one man, it can be kind of difficult to do, but I try my best. It's not something that I really ever apologize for. I don't care if it hurts feelings, because it's important to point out these things. I feel like a big reason why things are so acceptable nowadays to be spied on and have no privacy is because it's not called out. A lot of people don't make a big deal about it. And I tend to do just that. So it works out well. But when I point out companies or nonprofits or whatever, it's important to remember that these entities that I'm calling out, a lot of the times are not monolithic, I guess you'd say. They can execute brilliantly on one day and then just, catastrophically fail on the very next day, which is exactly why today, they're getting recognition for doing something right. Not to say that they've never done anything right, but it's important to recognize when something right is done, just like it's important to call things out when they're not right. So tomorrow, if the Tor Project turns around and they totally screw up, they'll get called out just as directly as this video, because that's the standard, and it doesn't really change just based on yesterday's performance. Privacy infrastructure in general is far too critical for grading on a curve, I guess you'd say, or giving passes because of past achievements, right? If you have an amazing piece of software and it's just all about privacy, and then they turn around and they put backdoors in it, it really doesn't matter anymore what you did, So that brings us to, more recently, I probably shouldn't have led with that. More recently, the Tor Project published their own VPN application for Android specifically. It's not really out for anything else. And the architecture actually changes mobile anonymity to a pretty decent degree. It landed on the Google Play Store on September 3rd, 2025, and is built from scratch using OnionMasq, which is basically a mobile-optimized Tor client library that's created from their Rust-based Arty codebase. And after letting the Guardian Project's Orbot handle Android VPN duties since 2009, Tor finally decided to build their own, and they stepped up and they did a really good job from what I've seen, and that's great. I'd say it's about time that they actually do it. Traditional VPNs work somewhat like routing all your internet traffic through a single company's server, which I know many of you know, but there are always people who don't. The distinction really matters, because in a minute, when we start talking about Tor VPN, it's not how that actually works. So that's why it's important to fully understand that architecture. For those who are new to my videos or whatever, haven't seen this or don't understand what a VPN is, that's essentially what it is. So basically, when you use this VPN, every website request or message in connection goes through that VPN company servers first. And as a result, they can see everything you're doing to some extent, right? In addition to that, they often log, things despite their marketing claims. This is true for, I would estimate the vast majority of VPN providers. Now, in addition to those claims of we don't log anything, they also hand it directly over to the feds or law enforcement whenever they come knocking, with little to no kind of bucking at all, whatsoever. Much of the time, they're very quick to get on their knees. Now, Tor VPN works completely differently because it actually embeds a full Tor client directly into Android's VPN framework using OnionMasq integration. Your traffic, just like when you use it on the Tor network, bounces through 3 random relays operated by different volunteers across different countries before actually exiting, where each relay only knows the previous and the next hop. Kind of like whispering a message, if you will, through 3 people where only one knows who whispered to them, and they're whispering it to the next hypothetical person. The technical architecture really shows why commercial VPNs seem very basic in comparison. So when XYZ VPN captures your packets, for example, which is like a VPN company I just made up as an example, they tunnel everything through one encrypted pipe into one server, right? Tor VPN assigns a link local address like 195.254.whatever, okay? Which are the addresses that are basically only accessible or cannot exist on the actual internet. Now, OnionMasq intercepts all traffic at these virtual endpoints and routes it through dynamic Tor circuits. And you can kind of think of traditional VPNs as a single lane highway to one destination versus this Tor VPN, which creates multiple winding paths through different countries for each app, right? Which is really kind of awesome. OnionMasq provides granular control that really shows how limited our kind of traditional VPNs can actually be. The implementation tracks get bytes received for app and get bytes sent for app for individual applications. Refresh circuits for app to actually route paths on a per application level, and get circuit country codes for app UID to show exactly which countries each app is routing through. Your Instagram traffic, for example, might travel through Germany, Poland, and Brazil, I don't know, while the signal simultaneously routes through France, Canada, and Japan. ABC VPN, which again is another fictitious VPN, sees one encrypted blog going to their server, so they physically can't distinguish between different applications, which is an important kind of note. Pluggable transport technology basically lets you disguise Tor traffic as completely different types of internet traffic, which is something that VPNs really can't do because they use this one fixed protocol, kind of like OpenVPN or WireGuard, well, it depends on whatever you're using, that have these recognizable signatures that sensors can fairly easily detect and block. You connect through OBFS4 bridges, for example, with Tor. Your Tor traffic kind of gets scrambled to look like random garbage data with no real discernible patterns. So things like DPI or deep packet inspection systems that governments use can't really identify it as Tor traffic. And Snowflake kind of works a little bit differently. It uses WebRTC, which is the same technology that powers video calls in your browser, to tunnel your actual Tor connections through volunteer proxies who essentially act as temporary bridges, making your traffic kind of look like you're just having a video chat with your friend. The app dynamically fetches new bridges through Tor's circumvention API based on what's currently working in your particular network environment. And this means when China blocks VPN protocols by recognizing their signatures, your ABC VPN subscription essentially becomes a paperweight. It becomes worthless overnight because it only knows one way to connect. When they block standard Tor traffic patterns, users can switch to something like OBFS4 to make it look like random data, or Snowflake to make it look like video calls, right? And by doing this, they get to keep connecting through completely different transport methods. The socket protection mechanism solves the routing loop problem that gave Orbot so much trouble for so many years. OnionMasq connections to Tor relays bypass the VPN tunnel through Android's protect function while user traffic gets captured and processed. And you could kind of picture two separate water systems where one carries OnionMasq's relay connections around the VPN, and another carries your app traffic actually through it. Traditional VPNs instead just dump everything into one pipe because they generally kind of lack that kind of architectural sophistication, right? So DNS resolution happens through virtual endpoints. So for example, whatever your endpoint is, right, like IP address, that exists only inside of your phone, basically. OnionMasq intercepts these requests and resolves them through Tor circuits, which means like your ISP never actually sees a single DNS query, not even encrypted ones heading to Cloudflare. So ABC VPN, for example, points you at their DNS servers where they probably log every domain that you actually requested. And this is how it's different. The event system, on top of that, also shows the network state at pretty impressive granularity in comparison to your typical VPNs. So Bootstrap event tracks consensus, download progress, new connection event logs complete circuit paths, including guard, middle, and exit relay identities. Failed connection event provides specific Tor error codes, and new directory event updates available relays by country in real time. So when we look at like commercial VPNs, for example, to give a comparison to that, typically they know like two states where the tunnel exists or someone cut it. So obviously it's a lot more complex. It's a lot more able. It's in a sense more intelligent in that way, right? And there are 3 protection modes too that we haven't even talked about yet. And they are kind of all like show the same kind of sophistication that we saw in comparison. For things like sophisticated traffic isolation specifically. They also have a protect all apps mode, and that kind of automatically excludes Tor and Orbot to prevent double routing. Selected apps mode protects specific applications while leaving others on the normal internet. And no apps mode, can you guess what that does? It's like, it exists for testing the actual implementation. Now, traditional VPNs basically have a power button because they generally can't conceptually separate different traffic streams. So again, this is pretty cool, and it's pretty revolutionary in terms of a VPN evolution, in my opinion. Now, the always-on VPN integration at boot requires downloading the current Tor consensus, building initial circuit pools, including network connectivity issues, and managing bridge connections before you even unlock your screen. And again, to me, anyway, like this was fairly impressive considering the fact that traditional VPNs are dumb and they just kind of reconnect to server number 47 and then call it a day. Like the state machine tracks these actual functions, right? And you have like init, connecting, connected, disconnecting, disconnected, and connection error with, specific substates for each consensus download and circuit building phase that you have. While other VPNs basically know green light, red light. So now what about circuit management, right? Well, this is, another kind of interesting approach, right, was one that was kind of adopted to be completely different from Orbot's approach. Thank God. While Orbot kind of utilized the legacy C implementation of Tor with SOCKS proxy integration, Tor VPN completely scraps like that entire thing. And instead, it embeds OnionMasq, which is essentially an Android optimized library, like we were talking about before, that is built on RD and it's in Rust. Again, just to reiterate, each protected app maintains a complete separate circuit and has like these circuit pools that actually rotate independently, pretty much making cross-application traffic correlation ridiculously difficult, but probably impossible, mathematically speaking. Anyway, like, it is really, really pretty interesting. And, your banking app, in this case, is never going to share relays with your social media, okay? So, like, Orbot kind of pushes everything through these shared SOCKS ports where correlation absolutely could still happen. Now, remember, like, this entire system ships as beta software with like very explicit warnings multiple times over against sensitive use. Again, I said against sensitive use. I just need to make sure that you actually heard that part. Like, they actually state that it might leak information. The actual support pages have these labels on them that say that too. They also say that they don't support tablets or Chromebooks right now. At the end of the day, they just kind of said screw it and ended up pushing into production anyway, right? Like, the F-Droid repository request from September shows that they had planned a wider distribution, basically, despite these kind of admitted flaws. So they're basically using early adopters as guinea pigs or test subjects for OnionMasq. So just keep that in mind if you rush off and install this, right? For those of you who've already installed it and have already started logging into various sites, this is why you watch the whole video. Also, remember, this is a Android-specific adaptation, again, based off the RD code base, and they do have liability disclaimers, again, everywhere for a reason, right? The automatic bridge discovery, to me, was really cool and shows a pretty significant leap in stuff like censorship resistance, which is incredibly needed at this time. So instead of manually copying bridge lines from emails where, it's like you're running on Windows 95, the circumvention API that they have dynamically provides bridges based on your actual network conditions. And this is like extremely cool, especially for those that lack the technical know-how or time or understand what bridges are or how to change them or why should they change them or any of those kind of things. And those like are the people that still want to be safe. It kind of makes it so that they are safe and makes it so they can't really not be safe because it automatically adapts for them to their environment. Incredible development, in my opinion. I think that's absolutely phenomenal. So commercial VPNs ship with server lists. That's kind of like the difference. And like, obviously, those server lists, any competent censor can block that before lunch. So Tor, essentially, they spent 20 years claiming that Tor browser provided sufficient anonymity. Then they turned around and built exactly what the community had actually been asking for since the smartphone existed. And the architectural elegance of embedding OnionMasq directly into Android's VPN service, rather than just proxying through SOCKS, really suggests that they finally understand mobile platforms actually need first-class support, right? The granular per app data tracking alone pretty much justifies its existence. So OnionMasq processes individual packets on a per application state. this actually enables metrics that no other VPN provider could really actually calculate for you. Like your, ABC VPN app might show total bytes encrypted to Switzerland, for example, while Tor VPN would show each app's individual usage, which countries it traveled through, and like when circuits were actually refreshed. For anyone conducting sensitive operations, again, you might want to stick with Orbot until this beta designation actually disappears. But for everyone else experimenting with mobile anonymity, this kind of implementation really delivers system-wide Tor routing with per-app isolation, automatic circumvention, and granular control. Just remember that they explicitly warned about potential leaks. So, and again, I know I'm beating a dead horse when I continually say this, but it's very important, so that's why I keep saying it. Now, this revolution really seems to be in Tor acknowledging mobile devices probably deserve equal treatment to desktops. That's true for a lot of reasons. One is that in a lot of countries that are not very wealthy, people don't have desktops and laptops, and maybe all they can get is a cheap phone. And after 2 decades of treating phones kind of as second-class citizens, if you will, they're building a platform for things that people actually carry. Whether they'll actually maintain this momentum or completely abandon it, like they did with Tor Messenger or Tor Cloud, and various other initiatives that died, that remains to be seen. We really don't know that yet. I really hope they do. I think they're onto something here. But that said, like the one thing I will mention is that if you're considering using, this thing for any kind of dark net operations, I highly suggest that you don't do that and you stick to using Tails or Unix or, Cubes or whatever it is that you're using. But what matters today is that Android users finally have like this native Tor integration that, generally surpasses commercial VPN capabilities in the most measurable dimensions, save for speed, right? Like it obviously is not going to bypass that, but you're essentially trading that velocity for actual anonymity, right? And that seems kind of reasonable when the alternative involves trusting corporations or like corporate promises to not log and believing in their retention policies. So it'll be interesting. I would love to hear what you guys think about this. Do you think it's a good thing? Do you think it's a bad thing? Do you think the volunteers that we have on the Tor, like, are they going to stop hosting because they know that people are using it as a VPN? I think there's a lot of interesting, ways to look at this entire thing. In any case, thank you for watching to the end. I'll see you in the next video.